Cambridge AS Computer Science, Chapter 9, Algorithm Design and Problem Solving, Part 3. We start from variables. Variables have been defined in the O-level because in the O-level you have been dealing with lots of variables. Okay? And we have seen here variables. My score is a variable. Index val is a variable. However, my array is not just a variable, it's an array. So this is an array that is something that is even bigger than a variable. Okay? So a variable is a storage location. For a data value, a variable will store only one data value that has an identifier that has a name. Soon we will be looking at what is called the identifier table. Okay? When we input data for a process, individual values need to be stored in memory locations. We refer to these named memory locations as variables. So a variable is a storage location in memory. Okay? We have seen plenty of variables. Okay? Okay, what is new? There is something called identifier table. So an identifier is the name of a variable. So, okay, so sometimes you may need to do an identifier table. Let me show an example. This is an example of an identifier table. Okay, let us read, and then look at examples. Identifier table is a table listing variable identifiers, which means variable names. Variable identifiers mean variable required for the solution with the explanation, with their data type and explanation. Okay, the identifier table need to show variable required to write a program in the algorithm. The identifier table will contain list of identifier variable names and data types. Which identifier will be of data type string? Which identifier will be of data type integer or data type real? You need to specify the data type. Sometimes in programming, you may need to do declaration. Declaration is assigning a data type to a variable. Okay. Also, the identifier may be used in the design of an algorithm to show names of variables, description of their purpose, and their data types. Okay. يبقى دلوقتي the explanation or description of what they are used for. Okay. Contents of the identifier table. Names of identifiers used. Data types of the identifier. Description of what identifier is used for. For example, the purpose of the identifier. The number of elements in the array. If the identifier is an array, then the number of elements in the array. Or the length of a string. If the identifier is text, the length of an example value or of any constant. The scope of the variable, we have a local variable and a global variable. We will be talking about this later. Okay, so this is an identifier table. This is an example copied from mark schemes. Example value, Wong. Okay. Explanation, the preferred name of the member joining the football club. What would be the variable name? Member name. What would be the data type? Will be of data type string. Okay. I think things in bold are answers. This is the mark scheme. The question contains the name and the explanation, and you add the variable name. The variable name should be meaningful. Don't put variable names that are just X, Y, or Z. If you have an example value false, the data type would be Boolean, because false and true, they come with Boolean data types. So the description says a value to indicate whether an existing member of the club lives at the same address. Okay, for example, call it family member, yes or no. Because he lives in the same address as his family, so he's currently with his family. Okay, so just call it family member or anything else because they allow for variety of answer. However, the data type must be Boolean. So 1902, 1983. This is of data type date. Definitely. Okay. And the description says, when the member joined the football club, how would you call it as a variable? For example, start date or join date or whatever. See, variables are meaningful and they have no spaces. They may not have a space. 1, 3, 4, 5. This should be an integer. The description says the number of points a member has earned, member of the club team points for different activity. Okay, I will call that points. Okay, so that's an example of an identifier table. If it appears, then it will be useful. Okay, then we go to programming. Let us go to programming. Programming, you have so many concepts, very simple concept. For example, you have assignments. Assignments is when you put a value in a variable. You also have a sequence. A sequence when instructions are performed one after the other in the given order or in a fixed order. Because the opposite or the alternative to a sequence would be selection. Logic statements that are selection. If then else, you may choose between different alternatives. Let us first do the simplest. Let us first do a sequence. Example, convert a distance in mile and output the equivalent distance in kilometer. Okay, write the program as a series of a structured statement English. Okay, so this is the program stated as the problem stated as a series of structured English statement. You know that we have three alternatives. Structured English, we have been through it. Pseudocode and also flowchart. We will keep playing and exercising with these until then. We will not be doing any structured English anymore, and we will do lots of pseudocode and lots of flowchart. Okay, this is mentioned in pseudocode. Input number of miles. Calculate number of kilometers. Output calculated result as kilometer. This is the algorithm in structured English. Okay. Okay, then we need to analyze the data values that are needed. We need a variables. Okay. We need a variable to store the original distance in meter and a variable to store the result of multiplying the number of miles by 1.61. It is helpful to construct an identifier table. Okay, so now we are going through an identifier table. Okay, what would be the identifier table? Okay, so we need a variable called miles, and the data type is real, which means it may carry decimals. This explanation, distance as a number of miles. We need km, that stands for kilometer, and the data type for it is real. And it is the result from using the given formula, that is kilometer is equal to miles multiplied by 1.61. Okay, we can provide more details by drawing a flowchart or writing a pseudocode. This is pseudocode, and this is a flowchart. and they both represent the same algorithm. Okay, so declare miles and kilometer as real. Declare miles, kilometer as real. Okay, so we use declaration to specify the data types. So miles will be real, kilometer is another variable of the data type real. Okay, and input enter miles, comma miles. This is a prompt. Whatever is here is a prompt. Okay, so the user will be asked to input the value in miles and then calculate kilometer from the given miles by multiplying it by 1.61 and output kilometer, comma, kilometer. This will show on the screen. Kilometer is km between quotation is subtext to show, and this is the value of the variable. So this is a representation of a very simple algorithm using pseudocode. Same here, the representation of the same algorithm, however, using a flow chart. So start, input, enter miles, and then accept a value for miles, which is like this. However, in flow charts, there are no variable declaration. You do not need to declare variables. Also in pseudocode, it may run without declaration. Okay, but sometimes if you create a function or a procedure, then your solution has to be complete with variable declaration. And variable declaration is another way of identifying the data types rather than an identifier table. So variable declaration is equivalent to an identifier table. Okay, so here, and as you can see, I would like you to learn rules of flowcharts. It has a start and an end. And the start is an oval, and the end is within a shape of an oval. Okay, inputs and outputs are written inside a parallelogram. So input, enter miles, this is the prompt, and then accept the value miles. Okay, kilometer is miles multiplied by 1.6. Whatever you accept here, you multiply it by 1.6. Output kilometer, comma kilometer. That kilometer between quotation is just some message to appear on the screen. The other kilometer is a variable, is the value of the variable. Okay, so that was an example in old days in a post paper. So you start with the structure English, you write the identifier table, you represent it as a flow chart or a pseudocode, and that's it. Okay, Shabab? So I hope this is very simple. Now we have to study various or available data types. Okay, because we are now writing an identifier table that selects a data type, or doing declaration that uses data types. Let us get introduced to data types officially. Programming languages can support different data type. Integer. Okay, however, I would like everything. I would like everything be in capital. So an integer in pseudocode is written like this. Real pseudocode is written like this. Char pseudocode is written like this. String. Okay, Boolean. And date. These are the data types available in programming. If you are using a database, string will be called text. Okay? Because we have to study databases in chapter 8. And if you have studied ICT O-level databases, will be easier for you if you have studied, because in ICT we do Access, which is a database. We do a query and everything. Okay, so integer whole sign number. Sign being positive or negative. Real sign number with a decimal point. Char, a single alphanumeric character, just a single character. String, a sequence of alphanumeric characters. Boolean, logical values, true and false. Dates, these are dates. Okay? Then declaration. Declaration in programming statements. Declaration is a programming statement that assigns a data type to a variable. Assigns a data type to a variable. Okay, let us go through this. We have very, very simple examples. Okay, declare HWR, perimeter, area, all as real. Declare A, B, C, D, E, all as Boolean. Okay, this is assignment. H will be assigned the value 13.6. And as H is real, assigning a 13.6 for it, it's not a problem. Okay, W assigned to it 6.4. And as W is real, you can assign to it 6.4. Okay, perimeter. Okay, you have to calculate that. Perimeter is H plus W, 13 plus 0.6 plus 6.4, that is 20. All multiplied by 2, perimeter will have a value of 40. That was a question, and that was the answer. That was the question, and that was the answer. Okay, next. Next. R10. So R, probably R is a radius. Area is 3.142, and this is the value of pi multiplied by r to the power of 2. This is in pseudocode means to the power of 2. Okay? Okay. So area now will be, so r is 10, r to the power of 2 is 100, 100 multiplied 3.142, and this is 314.2. Okay? Okay, Z, we put in it 11 plus R divide 5 plus 3. And the output will be error. Why? Because Z hasn't been declared. Z has not been declared at all. So Z will be error as Z identifier has not been declared. Okay? Okay, so this will result in an error. A not of R greater than 10. R greater than 10, let us see, R is 10. R greater than 10 is false. Not of false is true. So the value of A will be true. Okay, so that was an example. And these questions, these are even simpler than what used to be in O-level. However, these were in AS exam, so I thought I would teach. Okay, again here. These are all examples of a sequence where the code is just performed step after another in a sequence without selection, if then else or case. I will finish with that soon and then study if then else and case. Let us go through this example as well. Declare n1 as integer. Declare n2 as integer. Declare answer as real. Declare found as Boolean. Declare is valid as Boolean. N1 we put in it 3. Okay. N1 we put in it 3. N2 we put in it 9. Answer, that is N1 plus N2 all divide by 6. So 3 plus 9 is 12. All divide by 6. The answer will be 2. Easy? Okay, so the value of the first answer will be 2. Answer is 3 multiplied by n minus 2 and plus n divide 2. You have to follow the correct mathematical rules because n divide 2 will be computed, n minus 1 minus 2 will be computed, and the result will be multiplied by 3. So n is 3, minus 2 is 1, multiplied by 3, so this is 3, plus n2, n2 is 9, divide by 2, this is 4.5, 4.5 minus 3 is 7.5. Okay, Shabab? Okay, next. Is valid. Please notice that is valid is of data type Boolean. Is valid. N1 greater than N2. N1 is 3. N2 is 9. So this is false. So this is false. Because N1 greater than N2 is false. And N2 equal 9. Yes, M2 equal 9, this is true. However, you have here an and. This is false and true. The final value will be false. So is valid will hold the value false. Okay, found equal false. Okay. Is valid N2 greater than N1 greater than N2 divide 2. You have to do the N2 divide 2 first. N2 is 9, divide 2 is 4.5. Okay, so N1 is greater than 4.5. This is false. However, you have here or found equal false. This is true because yes, found has the value false. So false or true, the result is true. Okay, the last one. Answer is quotation. This is a string. And this is concatenate. This is in the insert. You are joining a string. So this string will be joined to that string, will be joined to that string. Why the answer is an error? Because answer is declared as real. Answer is not declared as a string. So you cannot do string manipulation and store the result in answer. When answer is declared as real, this will result in an error. Okay, so that was a bit of assignment. That was a bit of data types. That was a bit of declaration. That was some calculation. And that these are examples of programs running as a sequence of instruction without selection, without repetition. Let us now go to another concept in programming, that is the concept of selection. Selection is when you have, for example, a logical statement like this that has, for example, if then else. So with if, you have a condition. And then you have two alternatives. One alternative after the then and another alternative after the else. Depending on the condition here, this or that, either this or that will be performed. Let us go directly into examples because like this may cause even a bigger confusion. Okay? So this is if and then a condition. After the then, there is a sequence of select statements. After the else, there is another sequence of statements, and then to end with and if. If the condition here is true, you do that and skip that. If the condition here is false, you do the opposite. You skip commands after the then and do commands or statements after the else, because else means if not. A condition consists of at least one logical proposition. These are the logical proposition: equal, smaller, greater, smaller than or equal, greater than or equal, and this means not equal to. Logical proposition use the comparison relational operators. These are the operations. Conditions are either true or false. In pseudocode, we distinguish between relational operator equal. Equal here means test for equality. The equal here is test for equality. And that symbol means assignment. Okay? Okay, let us go through a very simple program. Okay? A program to find the biggest value in 3 numbers. Input biggest so far, input next number. If next number greater than biggest so far, then biggest so far become next number. And if input next number, if next number greater than biggest so far become next number. And if and output biggest so far. You shall try to figure out the purpose of this code, or you shall try to write a similar code yourself. Let me introduce this website for you. This website is some free website, probably created for IGCSE students. It is called Pseudocode Compiler. Actually, pseudocode is not meant to run on a computer. Pseudocode is meant to be calculated by hand. However, for clarifying the purpose or just showing what is going on, I'm just using this as a tool. Also, you may wish to use it and write codes with it. I don't think this website is perfect. Sometimes it misses things up for no reason. However, it is successful with very simple programs like this. Let us study here. I like to have a program that accepts 3 numbers and finds the biggest one out of those 3 numbers. Okay? Okay? So, input biggest so far. It will, let me run it. This is run, and this is input for a value, for the value called biggest so far. Okay, I put 20. Okay, so now biggest so far will be equal to 20. Is asking another, it is quite common that I take the first number as the biggest, because this is the biggest number I have seen so far. Okay, so remember that biggest so far now is 20. Input next number, I will put here 30. Okay, so now next number is 30. Now we have an if. If next number, that is 30, is greater than biggest so far, that is 20. If this is true, then biggest so far becomes the next number. I think this is true, and biggest so far now has the value of 30. Okay? Okay, so biggest so far now is 30. I think this is correct because I have entered 20 and 30. The biggest now is 30, and I think this is true. Okay, now is asking for another input for that, another input here. Let us say put here 15. Okay, so next number is now 15. If next number, that is 15, greater than biggest so far, that now has 30, I think this is false. So here, this will not be performed. And then the output will be, yes, excellent. The output now is 20, as expected. Okay, let us run it again. So I have here 10. I have here 30. I have here 15. Oh, it's not working. I don't know why it didn't work so well with that website. I have another website, and this is exactly the same code. This is exactly the same code. And when I run it, it is a little bit slow. So Input, for example, input biggest so far. So this is 10. So now biggest so far is 10. Input next number, this is 20. So now I think biggest so far now acquire the value of 20. Input next number for here, I will put 5. I think it's working here fine. The output should be 20. So this program in this website, because that website is causing incorrect results for I don't know why. Okay. Okay. However, for all, after all, you have to do pseudocode in a written exam. So you cannot be looking at compilers or tools like this. And if you are even, when you are doing paper 4 in Python, you will never be able to have access to the internet. Okay. However, I think those websites, please have a note of these websites and use them whenever you think it is reasonable. Let's go back to our notes. And that was an example of selection. I have an if with a condition. If the condition is true, the then will be performed. However, this example has no else. This example has no else. Okay. Let us see more examples. Let us see more examples. Horses are entered for a horse race. Actually, this example is copied from AS past papers, but maybe long time ago. You will not see it in my classified. Maybe that was on an exam in 2015 or so. I don't include such old exams in my classified. Horses are entered for a horse race. A horse may have to carry a penalty weight. Why would a horse would need to carry a penalty weight in addition to the rider? The penalty weight, if any, depends on the number of wins. If a horse is very strong and is winning so many times, we put an additional weight on that horse. So the competition will become a little bit with equal opportunity. The rule is like that. Depending on the number of wins the horse has achieved in the previous race. Okay, so the penalty weight is calculated as follows. When the number of previous wins is 0, the penalty weight is 0. When the number of previous wins is 1 or 2, the penalty weight is 4 kilograms. If it is something over 2, the penalty weight is 8 kilograms. Can we write this in structured English? Let us write this in structured English. Input name of horse. Input number of previous wins. Calculate penalty weight. Store penalty weight. Output name of horse and penalty weight. Okay? So that was the code in structured English. Let us now see the code in pseudocode. Input horse name. Input number of previous win. Race penalty weight. This is assignment. Race penalty weight is assigned 0. If number of previous wins equal 1 or number of previous wins equal 2, then race penalty weight equal 4. And if number of previous win greater than 2, then race penalty weight equal 8. And if an output horse name and race penalty weight. Okay? That was a very simple example using if then else. Again, we have an if without an else. Okay, let us go and study as much examples as possible. Okay, let us go and study several examples about selection and if then else. Okay, next. A team is designing a software system to monitor temperature in a process. The structure English for this: if temperature does not exceed threshold value, set the alarm state to off. Input threshold value to 2 decimal places. Okay, so this is, so the value is in 2 decimal places. Input sensor value, which is a whole number in range 0 to 100. Multiply sensor value by conversion factor 1.13. The value you get from the sensor is not the actual temperature. You multiply it by 1.135, and this is the actual temperature. If temperature exceeds threshold, set alarm state to on. If temperature exceeds threshold, output temperature alarm. If temperature does not exceed threshold, output temperature okay, and set alarm to off. So that was structured English. The procedure needs 4 variables. The identifier table below shows these variables. You need an alarm state that is Boolean, either on or off. You need a sensor value. This is an integer because it is here from 0 to 100. You have threshold value. This is real. You have temperature. This is real. The pseudocode equivalent of the structure English. So this is the program written in pseudocode. Alarm state, assign false to it. Input threshold value, input sensor value. Temperature is sensor value multiplied by 1.135. And then you do an if. If temperature greater than threshold value, then alarm state becomes true and the output temperature alarm. Else, which means temperature is not greater than threshold value. And then alarm state is false and output temperature is okay. So this is an example of if with an else. Okay? We may do nested if. What is nested if? An if inside another if. Okay? Nested if statements are conditional statements within conditional statement. You can put if inside another if. You can put as many if or other things inside each other, as long as you can handle this or you can correctly design or write the code for this. Okay, so nested if statements are conditional statements within conditional statement. When an if statement contains another if statement, we refer to these as nested if statement. So a nest is the house of the bird, and you find sticks nested inside each other. Okay, let us read this example, because we have here an if inside of another if. We call that nested if. So in a number guessing game, we would like to guess a number. We have RND is a built-in function that generates a random number. See, now they are talking about a random number generator. There is, or there could be, a random number generator in the insert. But why here it is written differently? It is written differently. Yes, that example was a long time ago, before they invented using the insert. Okay, so RND or random, or the way they call it, use it the way they call it and the way they describe how it will work. So RND is a built-in function that generates a random number. So secret number is RND 1,100, which means the computer will select a random number, randomly something between 1 and 100, and put it in a variable called secret number. And then you have to enter your guess. If guess equals secret number, then well done. You have guessed the secret number. Else, which means you haven't guessed the secret number. You have now two other conditions. either if guess is greater than secret number or if it is not. So if the guess is greater than the secret number, there will be a message that say secret number is smaller. It is kind of a clue to help you make a better guess. If not, then get another message. The secret number is smaller. The secret number is greater. Because they will never be equal. Because the equal will be here. So I have an if inside of another if, and I call this nested ifs. Okay? What else? How far can we go? Okay. We have plenty of examples about if then else. And then we have flowcharts about if then else. Okay? Let us see if we can go and do things from the classify.